Greetings all. I hope you guys are staying safe and keeping well. In today's video we will be tackling the third question in November 2019's paper 1. Without any further ado, let us get into the math. So question 3.1 says, without using a calculator, determine the value of the sum of 1 over y minus 2 from 3 to 10 minus the sum of 1 over y minus 1 from 3 to 10. We can start by just breaking up what this first term represents. So what is this sum of from y equals 3 to 10 of 1 over y minus 2? Well, that's just the sum. If we plug 3 into this term over here, we will get 1 over 3 minus 2, and then we're going to add the next one, which is going to be when y is equal to 4, and we're going to plug y into it, so it's going to be 1 over 4 minus 2 plus 1 over 5 minus 2, and this goes on all the way to 1 over 10 minus 2. If we just simplify this, we will get 1 over 3 minus 2 is 1, plus 1 over 4 minus 2 is 2, plus 1 over 5 minus 2 is 3, plus all the way to 1 over 10 minus 2 is 8. So now that we have the first expression, we can see that it's just 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 all the way to 1 over 8. So now let's find out what this next expression means. Or actually, let's do it in a different color. So what does this expression mean? Well, this expression means 1 over 3 minus 1. So the first value is going to be 3. 1 over 3 minus 1, so substituting 3 in, plus 1 over 4 minus 1, plus 1 over 5 minus 1, plus all the way to plus 1 over 10 minus 1. And then we can close that bracket. And then let's simplify this. And when we simplify it, it will be 1 over 2 plus 1 over 3 plus 1 over 4 all the way to 1 over 9. So we have this section over here. We know what that term is, and we know what this blue term is on this side. And now I'm going to evaluate what these terms are together. Okay, so the blue term is going to be 1 over 1 plus 1 over 2 plus 1 over 3 plus all the way to 1 over 8. And then that is going to be minus 1 over 2 plus 1 over 3 plus dot 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 plus 1 over 9. And now we need to think about what this minus would do, how it would collapse this entire thing. We are going to end up with something that looks like this. First of all, let's think about what happens over here. We have 1 over 1 plus 1 over 2, but we also have a minus 1 over 2 over here. So these two are going to cancel each other out. The 1 over 3s are going to cancel each other out, and all of these values are going to cancel each other out in the middle, and this 1 over 8 is a 1 over 8 over here as well, and all that is going to be left over is 1 over 1 minus 1 over 9, and we can actually say that is 9 over 9 minus 1 over 9, and that is equal to 8 over 9. And that is our answer. When you see a question like this, it's better to just expand it first and see what you're working with instead of actually doing it all piece by piece, or again, it says without using a calculator to determine. So if you just use your calculator, then you would not receive the marks. Just try expanding them and you should arrive at the correct answer. So question 3.2, they say that a pavilion at a sports ground comprises of a series of 12 steps, of which the first 3 are shown in the diagram, and then we have a diagram, and they say that each step is 5 meters wide. We'll come to know soon that that piece of information is actually useless, and we won't be using it in any of our calculations, and it's maybe just to throw you off. Each step has a rise of 1 over 3 meters and has a tread of 2 over 3 meters. The open side on the sketch of the pavilion must be covered with metal sheeting, and we need to calculate the area of metal sheeting needed on both open sides. So if you look at the diagram, there's a shaded area on the right hand side. We have to find the area of all of those for the 12 steps, and then we have to multiply that by 2. I drew a sketch of what the side would look just for the first 3 steps, and first thing we can note is just the sizes of all of these. The rise is 1 over 3, and the tread is 2 over 3, and then it rises by 1 over 3 again, and that is also 2 over 3, 1 over 3, and 2 over 3, and we need to find the area. So what we're going to do here is we're just going to separate this into 3 different sections. We're going to have a green section over here. We're just going to calculate that green section alone, and then we're going to calculate this blue section, and then we can finally calculate this orange section, and you can see if we see any patterns within these sections. So firstly, what is the area of this green section? Well, that's easy enough. It's the area of a rectangle is length times breadth, so this would be 1 over 3 times 2 over 3. And now over to the blue section. The length of this one is going to be 2 over 3 because you're taking 2 steps up, and then the width is going to be 2 over 3 as well. So our length times breadth is going to be 2 over 3 times 2 over 3. And lastly, for this orange section, you're going to have 3 over 3 times 2 over 3. And you can already see a little pattern forming. First one is 1 over 3 times 2 over 3. The next one is 2 over 3 times 2 over 3. The next one is 3 over 3 times 2 over 3. And the following one will probably be 4 over 3 times 2 over 3. And now we can note that the area is equal to the sum of all of these things. So let's write that down. Area is equal to 1 over 3 times 2 over 3 plus 2 over 3 times 2 over 3 plus 3 over 3 times 2 over 3. And this is going to go all the way on until we get to 12 over 3 times 2 over 3. And what we can do here is we can actually take out a common factor, and the common factor that we are going to take out is this 2 over 3 because it is present in all of the terms. So we're going to be left with 2 over 3, and we're going to take it out, so we're going to be left with 1 over 3 plus 2 over 3 plus 3 over 3, and that goes all the way until 12 over 3. We call this an arithmetic sequence, and there's a formula, or actually an arithmetic series, but arithmetic sequence or series. And in order to add all of this up, we use a formula that I'll write down now. So that's our formula for an arithmetic sequence or the arithmetic series, and all we need to do now is substitute the necessary variables or values into the variables. But first of all, what does n, a, and d represent? Well, let's first just write this out. 2 over 3. It's going to be n over 2, and n is the number of terms in the sequence or series that you are adding up, so it's a series, and the number of terms that is in it is 12, because there's 1, 2, 3 all the way to 12. So we know that n is equal to 12, so we're going to say 12 over 2. That is multiplied by 2a, and a is the first term in the series, and the first term in the series is 1 over 3. Then we have plus n minus 1. Okay, we already discussed what n was. N is 12 minus 1. And lastly, we have d, and d is the difference between each term in the series, and the difference between each term in the series is 1 over 3. You are adding 1 over 3 every time to get to the next term, so we know that that is 1 over 3. Now if you plug that into your calculator, you should get an answer of 52 over 3 meters squared. And remember, this is not your answer just yet, because this is only the one side of the staircase. We need to find out what the other side is well. So it's actually, you have to multiply that by 2 because it's 2 sides. So in the end, your answer is going to be the area of both sides is equal to 52 over 3 times 2, which is equal to 104 over 3, and that is equal to 34,67 meters squared. And I think that makes a lot of sense. It is a bit long to do this type of question because you actually need to visualize what is going on, but it is worth 6 marks, so I would definitely suggest taking your time with this question, with a question like this at least. Just before we end, let me leave you with this quote: "A failure is not always a mistake. It may simply be the best one can do under the circumstances. The real mistake is to stop trying." B.F. Skinner. Keep well and be blessed.